276 paid fans. So for this problem, we are giving two integers n and k. Yeah, so yeah, and we must paid the post following these rules. So we are paiding a fans of n posts, so we are giving n posts and with k different colors. Yeah, and we're gonna pay to the posts, and we have to follow on these rules. So the first rule is that every post must be painted exactly one color. So for example, this post painted with yeah, maybe this is a pink and gray. Yeah, so there cannot be 3 or more consecutive posts with the same color. So this means for the consecutive post, for those 3, it cannot be the same color. It cannot be the same gray or same red. Yeah, let's just call this color red. Yeah, so we are giving those two integers, and we're going to return the number of ways we can paint the fence. Let's just check the first example. So we have n posts with 2 different colors. Yeah, so there are going to be 6 different color of cases. So for example, 2 red, 1 blue, and red, blue, red, and red, blue, blue. And now we're gonna start with blue. So blue, 2 red, and blue, red, and blue, and blue, blue, and red. Yeah. We cannot make like 3 blue or 3 red. Definitely, it is not possible. Yeah, we cannot make like 3 blue or 3 red because according to the problem, we cannot do that. So this problem is similar to the house robbing problem. So for the house robbing, yeah, if we rob a house, we cannot rob the consecutive house. We have to rob the next one. And this is the same. Yeah. So the condition is that we cannot paint 3 posts with the same color. We cannot paint 3 consecutive posts with the same color. Yeah. So now we should know that we can solve it by using dynamic programming. So the condition is that, so for example, if we paint the first house with blue, if we paint the first fence post with blue, and the second with blue, can we paint the third with blue? No, we cannot. We cannot paint the third with blue. Yeah. So similarly, for the same idea, if we are using the red, so the first one is red, and the second one is red. Can we paint the third one with red? No, we cannot. Yeah. But what if we only have 2 posts? So if we only have 2 posts and we have k different colors, so if we have 1 post, so how many different ways? It's going to be k different ways. So if there are 2 posts, so it's going to be k times k different ways. Yeah, but what if the number of the posts is more than 2? It is more than and equal than 3. So what are we going to do? So there are going to be 2 conditions. Yeah. So let's just analyze it. So this is the first one, and this is the second one. So what about the third one? Of course, the third one cannot be the same color. So let me just use another color. Yeah. So the third one cannot be the same color. So this means this color is different from this color. So let's just set how many different ways for this one. It is fn minus 2. And how many different ways for this one? It is fn minus 1. There are going to be fn minus 1 different ways. So this is just imagine if we know how many different ways. If we paint until this one, there are going to be fn minus 2 different ways. If we paint until this one, there are going to be fn minus 1 different ways. So this is fn. And how many different ways for this fn? It depended on the color. So if this color is different from this color, it's neighboring color. So how many different ways? It's going to be fn minus 1 times what? K minus 1, right? Yeah, because this is going to be k different colors, so definitely we're going to paint a different color. So this is one color. If it is different from this color red, there must be k minus 1 different colors. So how many different ways? Yeah, so it's going to be fn minus 1 times k minus 1 different ways. Yeah, so for example, from here, we know that it's going to have fn minus 1 different ways. So if we pick a color maybe white, So it's going to be fn minus 1. If we pick another color, maybe gray or maybe other colors, it's going to plus how many different ways? It's going to be k minus 1 different ways. So it's going to be fn minus 1 times k minus 1. So we should understand this color formula. Now, the condition is that what if we paint the same color red? So what if we paint the same color red here? Yeah. So if we paint the same color on red, so this means this color is the same as the neighboring color, but this color must be a different color. Maybe we're gonna make it, make it white. So this means this one gonna be a different color. Maybe it is white. But how can we calculate it? So it's gonna be 1 times, because it is the same color red. So before it's gonna be fn minus 1 different colors, right? Yeah. So because here is fn minus 1. But this fn minus 1 is dependent on the previous color. It must be a different color. Yeah. So here fn minus 1 gonna equal to this one, fn minus 2. Yeah, because here this is red, but before it must be a different color. So it means it's gonna equal to fn minus 2. So here it means fn minus 2 times k minus 1. Because here, so for example, this is if this is white, so this means here this color must not be white, must be another color. It can be any other color, must not be white. If it is a different color, it's going to be fn minus 2 times k minus 1. So now what are we going to do? We just plus them together. So this is the fn minus 1 times k minus 1. This means this is red and red. It's the same color with its previous color. It is the same, red and red. Another way is this means the previous color is different, fn minus 1 and k minus 1. And another way here is the previous color and the current color. It is the same, but for this color, with its previous color, it must be different. So it's going to be 1 times fn minus 1. It's going to equal to fn minus 2 times k minus 1. Yeah, because for this is red, the previous one, how many different ways? It's going to be n minus 2 different ways, but it must be a different color. So it means up to here, fn minus 1, it's going to times k minus 1. Yeah. So now we're going to plus them together. So it's going to be k minus 1. It's going to be k minus 1 times fn minus 1 plus fn minus 2. So this is the formula. We just needed to use this formula to solve the problem. Yeah. So the formula is fn gonna equal to fn minus 1 plus fn minus 2 times k minus 1. Yeah. So according to the formula, let's just write dynamic programming. So we're gonna define a function f. So inside I'm gonna set it as I. It means how many different posts. So if there's only one post, we're gonna directly return the color. So if there are gonna be 2 posts, so we're gonna return k times k. Different combinations. What else? Else is that we just need to copy and paste this one. Yeah, we just need to return fi minus 1 and I minus 2 times k minus 1. So finally, we just need to return fn. Yeah, so this is going to be the formula to solve the problem. Now let me just run it and submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is, let's check. So the time complexity is O(n). And n is like 50. Yeah, because as we know it from here, it is just dependent on this I. This is going to be the time complexity, because from here there's no for loop, and this is only I, and I is going to be from 1 to 50. So the time complexity is going to be O50, going to be O(n). Yeah, it is not dependent on k. K is just like a constant number. We use it to calculate, but the final result, the time complexity, only depended